All right, so today we're going to do a deep dive into some computer networking fundamentals.
Yeah.
And we've got some practice questions here from a Nokia certification exam,
Mhm.
which I always think is fun to kind of get inside the head of like how network engineers are thinking.
Yeah. Always good to refresh.
Even for someone like you who's been working with networks for a long time, maybe we'll uncover some stuff that you're like, oh, I haven't thought about that in a while, or I didn't know that.
Yeah, definitely. Always a good refresher to go back to the fundamentals.
Yeah.
Sometimes you can find some interesting insights.
Okay, so this first question is about ARP, which is Address Resolution Protocol, and its counterpart in IPv6, which is neighbor discovery.
Right.
And this is something that like most people have no idea is even happening behind the scenes when they connect to a network.
Yeah, it's like the glue that holds everything together.
Okay.
You know, think about it like you're sending a letter,
Mm-hmm.
but you only have the street address. You don't have the person's name. You need both to make sure that letter gets to the right person.
Okay, so in this analogy, the IP address is like the street address,
Exactly.
and the MSC address is like the person's name.
Yep. And ARP for IPv4 and NDP for IPv6, they both basically work to map an IP address to a MC address.
Okay.
And it's a crucial process because devices use IP addresses to communicate over a network.
Mm-hmm.
But on the hardware level, they need MSC addresses to physically send those data packets.
So even though I might think about like I'm connecting to google.com or facebook.com or whatever using an IP address,
Yep.
that ultimately gets translated down to a mass address to make sure the data actually gets to the right piece of hardware.
Exactly. And this mapping happens all the time
Wow.
without us even realizing it.
Okay.
But here's where it gets a little interesting.
Okay.
ARP in particular has some security vulnerabilities
Hmm.
because it's based on trust. It's susceptible to something called ARP spoofing.
ARP spoofing. Okay, that sounds kind of shady.
It can be.
Yeah.
An attacker can send out fake ARP messages and basically trick devices on a network into associating the wrong MSC address with a particular IP address.
Okay.
This allows them to intercept network traffic or even redirect it to a malicious server.
So someone could be like listening in on my networked activity or stealing my data
Yeah,
by messing with these ARP messages.
potentially, yeah.
Oh.
And that's why network security measures are so important. Things like implementing ARP inspection on network switches to prevent these types of attacks.
So even a concept like ARP, which seems pretty basic, has like some real security implications if you're not careful.
Absolutely.
Okay, so moving on, the next question is about routing tables.
Okay.
And I remember learning about these back in the day,
Hmm.
but honestly, they always seemed kind of abstract to me.
Yeah.
Like, what is the practical importance of a routing table in a network?
So think of a routing table like a map for your data packets.
Okay.
Routers use these tables to decide where to send each packet based on its destination IP address.
Hmm.
Without routing tables, networks would be chaotic and inefficient.
Okay, so the router basically looks at the destination IP address on a packet
Yep.
and then consults its routing table to be like, okay, where do I send this thing?
Exactly.
Okay.
And this process happens so fast, like millions of times per second on busy networks.
Wow.
So the efficiency of routing tables is really critical for overall network performance.
Okay, so it's not just about getting the data to the right place, it's about getting it there quickly.
Absolutely. And there's also another layer to this. Routing tables also play a crucial role in network security.
Okay.
By configuring specific routes and things like access control lists, network administrators can control the flow of traffic and prevent unauthorized access to sensitive resources.
So you can use a routing table to like block traffic from certain IP addresses or prevent devices from accessing like certain parts of the network?
Exactly. It's like setting up virtual fences within your network to control the movement of data and protect critical assets.
Okay, so routing tables are way more important than I initially thought. Yes.
Very important.
This next question is about how routers choose the best path when there are multiple options.
Right.
And it mentions this thing called administrative distance.
Yes, administrative distance helps routers prioritize different routing sources.
Okay.
It's essentially a way of ranking the trustworthiness of different routing protocols.
Hmm.
Think of it this way. You have a GPS, a paper map, and your friend giving you directions.
Okay.
Which one would you trust the most?
Probably the GPS these days.
Exactly.
Yeah.
So the GPS would have the lowest administrative distance.
Hmm.
Routers work in a similar way.
Okay.
They prefer routes learned from more trusted protocols.
Got it.
For example, they typically trust routes learned directly from a connected network more than routes learned from another router.
Okay,
So administrative distance helps routers make informed decisions about which paths are most likely to be reliable and accurate.
got it.
Yeah.
So it's not just like blindly picking a path. It's saying, okay, I trust this source of information more than this other source.
Yeah.
Okay. Now, this question mentions something called the routing table manager,
Right.
or RTM.
Yep.
Is that what's actually making the decision based on administrative distance and all these other factors?
You got the RTM is like the decision maker within the router.
Okay.
It evaluates all the available routes,
Mm-hmm.
considers things like administrative distance, metrics like bandwidth and delay, and even policy settings defined by the network administrator.
Oh, wow. So it's not just a simple lookup table. There's like some real logic going on there
Exactly. It's
What-
quite
to
complex.
determine the best path.
Absolutely. And this decision-making process is what allows networks to adjust to changing conditions.
Okay.
For example, if a link goes down, the RTM can recalculate the best paths and ensure that data keeps flowing smoothly.
This is making me think about, I had a situation a while back where my internet connection kept dropping,
Uh-huh.
and I had 2 internet connections configured on my router,
Right.
but it wasn't like automatically switching over to the backup connection when the primary one failed.
That's a classic example of where understanding administrative distance and routing table management is so crucial.
Huh.
It's likely that the routes for your backup connection weren't configured correctly,
Yeah.
or they had a higher administrative distance,
Hmm.
which prevented the router from using them when the primary connection went down.
So if I had understood this stuff better,
Yeah,
I could have like diagnosed that problem myself and potentially fixed it.
exactly. And that's the power of understanding these fundamental networking concepts.
Hmm.
It empowers you to not only use networks effectively,
Yeah.
but also troubleshoot and optimize them to meet your specific needs.
Okay, cool. So this next question we've got is about IPv6,
Okay.
which I know is kind of like the next generation of internet addresses.
Right. And you might be thinking, didn't we already cover this with ARP?
Yeah,
But remember, ARP is specific to IPv4.
right.
IPv6 has its own method called Neighbor Discovery Protocol, or NDP.
So NDP in IPv6 kind of takes over all the functions that ARP was doing in IPv4.
Exactly. It handles address resolution, router discovery, and neighbor unreachability detection, all within the IPv6 framework.
Okay. Why do they need a separate protocol? Is it just because IPv6 uses a different addressing scheme?
It's more than that.
Okay.
IPv6 was designed to really address some of the limitations of IPv4,
Mm-hmm.
and NDP is a key part of that.
Okay.
One major advantage of NDP is that it's more efficient than ARP.
Okay.
It uses multicast messages, which means it can communicate with multiple devices at once,
Hmm.
reducing network overhead.
So it's like less chatty.
Yeah, exactly.
Okay, that makes sense because efficiency is always a good thing,
Oh,
especially as networks keep growing and more devices come online.
absolutely.
Okay, speaking of efficiency, this next question is about something called a designated router,
Right.
DIS.
Yep.
What is the purpose of having a DIS in a network?
So in some network protocols like IS-IS, a DIS is elected to act as a central point for distributing routing information within a certain area of the network.
Why do you need that extra layer of coordination? Why not just have all the routers talk directly to each other?
So think about it this way. If every router in a large network was constantly sending out updates about all of its connected networks, it would create a ton of traffic.
Right.
It would be very inefficient and could potentially overwhelm the network.
So the DIS is kind of like a traffic cop,
Exactly.
controlling the flow of all this routing information to
Yeah.
make sure the network doesn't get congested.
Precisely by having a designated router handle those updates, we reduce the amount of chatter on the network
Okay.
and make sure that the routing information is disseminated efficiently.
So again, it's all about optimizing network performance by reducing unnecessary traffic.
Exactly. And there's another benefit.
Okay.
Having a DIS helps prevent something called a network loop.
A network loop? What's that?
Imagine a scenario where router A learns a route to a destination through router B.
Mm-hmm.
But router B also learns a route to that same destination through router A. This creates a circular path for the data packets, causing them to just bounce back and forth endlessly.
So the packet gets stuck in like an infinite loop
Yep.
and never reaches its destination.
Exactly like being stuck in a roundabout forever.
Yeah.
The DIS, by controlling the flow of routing information, helps prevent these loops from forming
Okay.
and ensures that data can reach its destination reliably.
So it's a very important role, this designated router.
Yes, very important.
How do they actually choose the DIS?
So when multiple routers on a network segment are capable of becoming the DIS,
Mm-hmm.
they compare their router IDs.
Okay.
The router with the highest router ID wins the election and becomes the DIS.
What is a router ID?
So the router ID is a 32-bit number
Okay.
similar to an IP address that uniquely identifies a router within a network.
Okay.
In some cases, the router ID might be manually configured,
Okay.
but in many implementations, if it's not manually set, the router will choose its highest IP address as its router ID.
So the router with the biggest IP address gets to be the DIS.
Uh-huh. Yeah, you could say that.
Kind of a digital popularity contest.
Yeah. But it's important to remember that the router ID is just a mechanism for choosing the DIS.
Right.
The real purpose of the DIS is to streamline routing information and prevent network instability,
Got it.
not to crown a king of the network segment or anything like that.
Once you understand the basic rules, you can communicate effectively, even as the vocabulary and expressions change over time.
Exactly. And just like learning a new language, learning about networks opens up a whole new world of possibilities.
Yeah.
It allows you to connect with people, share ideas, and explore new frontiers.
Well, I think that's a perfect note to end on. Thanks for joining us on this deep dive into the world of computer networking.
Yeah, it's been a pleasure.
We've covered a lot of ground today, but hopefully you've gained a deeper understanding of how networks work.
Yeah.
And a little bit about all the exciting possibilities that are out there.
For sure.
So until next time, happy networking.
Happy networking.